Hello, good afternoon, and welcome to another Big Data London webinar. So today we're tackling data observability. So I'm Andy Steed, Content Director at Big Data London, and I'm joined today by Kevin Hu from Metaplane, and he'll be doing the featured presentation in a moment. So these sessions are designed to be interactive, so do ask any questions you have. Obviously, I think we're all quite keen to find out a little bit more about data observability. So make sure you ask any questions of anything that you want Kevin to expand on, or anything that you want a little bit more info on. The question box is underneath this video screen here, so to the left. If you lose the stream at any point, please do just hit refresh in the browser and you'll jump straight back in. No worries. Back where you left us. So next to the question box, we have the attachments section. Just want to make a quick note to that. Registration for Big Data London, the event is open. So do click on that and make sure you get registered to come and join us in September. You can meet Kevin there. He's going to be there with Metaplane, as well as lots and lots of other folks. And we've added 3 theatres this week. So for the first time ever, we'll be having more than 200 sessions over the 2 days. So lots and lots of work ahead. I also wanted to mention the YouTube channel, which is in there, just before I hand over to Kevin. There's a way, obviously, subscribe to the channel, and every time we upload a new video, you'll get a little notification. We're adding lots and lots of stuff at the moment. Really good practical stuff like this about, what is some of these new trends that are coming out. I know there'll be a data mesh session. We've obviously got this data observability session. So maybe a chance for you to catch up on all the new things before you come to Big Data London, where you can ask people like Kevin yourself in person. So enough from me. Now we've got a chance to hear from our featured presenter. So over to you, Kevin. Please do take it away.
Hi, everyone. Good afternoon, or good morning, or good evening, depending on where you are in the world. In Zoom, you can't tell anymore. I'm Kevin Hu. I'm the CEO of Metaplane, and I'm so looking forward today to talk to you about data observability. Let me just pull up that slide. Perfect. Can everyone see that okay? Perfect.
Yeah, that's all good. I'm gonna stick us in there as well. There you go, so they can see you.
So data observability feels like a very modern concept, and it is. You probably haven't started hearing of this term before the last couple of months, or maybe a year if you're really tapped into the data ecosystem. But today we're going to stretch a surprising amount of time. I put in 1788 because that's when Christian Huygens discovered the centrifugal force to 2032, but we're actually going to start a little bit before then. But before we get into that, I'm Kevin. I'm the founder of a tool called Metaplane, a data observability tool that you can use within 10 minutes. I promise you that I'm not going to shill too much during this talk until the demo. But if you have any questions, please put it in the chat or just send me an email. I love to talk about all things data, whether you think, oh, hey, data observability is really interesting. I want to learn more. Or, hey, this is all BS. I want to give you a piece of my mind. Please just feel free to message. So without further ado, I know that last week you all had a fantastic webinar about data ops, and data observability, we feel, is part of the data ops philosophy. But before we talk about how data observability fits into how companies can use the new technology, we want to talk about, 1, what is the history of data and observability? 2, what the heck is this, right? What are the components of data observability and how do we define it? And finally, how do you put it into practice? So let's start with the history. And let's start specifically with a piece of data. And this isn't data as we're particularly familiar with it, but it's one of the first extant pieces of writing in human civilization uh, from ancient Babylon. It's from Sumeria, and you might expect that this clay tablet is about some mythological story or some edict from a king, but it's literally a total of 29,805 measures of barley were received over the course of 37 months. Signed, Kushim. And if this sounds familiar to anyone, you may think that this is a Salesforce transaction, and you'd be correct, because many of the first pieces of writing that we have, as you can expect, are pieces of data, right? I do not want to remember that, I just received 29,805 measures of barley. So I want to put it somewhere. And in some ways, our technology has come a long way since then, right? You can probably store more data. Uh, in other ways, it's not quite as good, right? Clay had autosave, but in many ways, we're just riding that technological curve. And it's not all sales data. It also includes customer support data. This is the first known customer complaint as written, that we have available to us in modern day. It says, I will give Gimel when he comes fine quality copper ingots. You left then, but you did not do what you promised me. And clearly, this is quite a long support ticket because they get all into contractual obligations, what you're going to do because you didn't deliver these fine quality copper ingots. But this is Zendesk. And if data is old, data quality issues are also quite old. This particular piece of cuneiform has several typos in it, and typos are quite common in the day. And if you dig back far enough, I believe there are instances where there's a lot of misinterpretation because of these data quality issues. But the point that I'm trying to make is we can go back 6,000 years and we have people writing down data on physical artifacts. And since then, we've seen a bit of a progression where writing on physical artifacts has transitioned into digital forms of storage. The real shift has been in the 1970s with the great Edgar Cod at IBM, who had the insight to say, okay, most things in this world are objects, and we can put those objects as rows in a table. And those objects have attributes that we can put as columns, and the relationships between those objects we can codify with foreign key or in general like table relations. And finally, on top of this, we can have a well-defined set of operations formalized as a relational algebra, but actually put in practice with what we call SQL over the relational database. And really, we've been riding his insights for the past 50 years. From the original massive on-prem databases like DB2 to the 2000s, we shifted towards still on-prem, but columnar data stores that take advantage of analytical queries, mostly running on columns versus rows, although I'm preaching to the choir here. And finally, to the past decade, whether it's 2012 with the invention of Redshift, to BigQuery and Snowflake, where thank you Moore, like Dr. Moore from Moore's Law, where the price of storage and compute is exponentially shrinking, and we're benefiting from that with being able to store more and more data and have infinitely scalable compute. So finally, I think Kushim would be proud of us that we're fulfilling some of the major promises of data. And I'm not trying to say that data wasn't useful before, because of course it was. Some of the original applications of software itself was data processing and decision support. And business intelligence will forever probably be one of the main veins of data throughout an organization, because businesses will forever have to make decisions with a shifting competitive marketplace landscape. But clearly something is changing, where modern data teams are collecting data from more and more applications. Your company probably has dozens, if not hundreds, of databases and SaaS applications, extracting and loading it into data warehouses where you can store a terabyte of data for $23. Insane. But most importantly, data is being used for more and more use cases, right? BI, of course, Looker and Tableau will always be here, but also to make predictions via machine learning and artificial intelligence, to power go-to-market operations by putting product data back into Salesforce, to drive automations or to put data into your actual product to improve the customer experience. Now, this is fantastic because in many cutting edge organizations, data is used by everyone. Everyone is either someone who produces data, for example, a sales rep putting in a contract, who transforms data, or who consumes data. So data is finally spreading from this one vein throughout the entire body of an organization. However, every piece of progress has its downside. And for us, what we see is okay, you as a data practitioner are responsible for hundreds, if not thousands, if not tens of thousands of assets. Raw data, transform data, your BI dashboard. And this is a whole lot of surface area to maintain. However, we found that most organizations subscribe to what we call EDT, or executive driven testing, where your VP of sales or your CEO only cares about one dashboard, which is the one that they're currently looking at. And of course, they're the master of that domain and they're tracking that number. So while the surface area of data to maintain goes up and up, there's so many opportunities for breakage. And frequently, it's the downstream users of that data, the stakeholders, who are the first to find that breakage, which leads to lost trust. And once you start losing trust, wow, we know that that is an uphill battle, right? Tons of one-on-ones, people spinning up shadow data stacks. We've heard the whole thing, and this whole process kind of gets short-circuited. So the problem, to put it another way, is entropy. Whereas time goes on and you create more and more data assets, the amount of disorder tends to increase. But we can draw from another discipline where we've seen the amount of assets increase and increase and the amount of use cases increase and increase, which is software engineering. And specifically, in the past decade, we've seen the rise of software observability tools like Datadog and New Relic and Sumo Logic and SignalFX. And what they propose is, okay, you have so many, you have so many boxes running in your infrastructure, databases, API gateways, Kubernetes clusters. And what we care about is to extract three pillars of information: metrics, traces, and logs. Metrics that describe the internal characteristics of a piece of your infrastructure, traces, which are time correlated logs, and logs, which is like every minute interaction that is happening. And put together, we can use these three pillars to reconstruct in arbitrary detail the state of your software infrastructure today, going back and try and predict it a little bit in the future. So we can, get some inspiration from software observability, and that's clearly where the name data observability comes from. However, we have to keep in mind that software observability copied the name of observability from control theory. And control theory goes surprisingly far back to the 1700s. Now, on the left, you're looking at Christian Huygens. He was a contemporary of Isaac Newton. I believe they wrote a lot of letters back and forth at some point, although everyone wrote letters back then. And like all the polymaths of the time, when he wasn't busy studying the rings of Saturn, he discovered or really formalized centrifugal force and specifically created this device called the centrifugal governor. Now, Huygens was Dutch, and if you think of the Netherlands or Holland and imagine windmills, you wouldn't be so far off. And back then, windmills, the primary use case was to grind wheat. And the problem was wind has variable speed, while wheat has an optimal, your millstones has an optimal rotation rate. And if it goes too fast, it can cause sparks, it can cause poor quality flour. So Huygens invented this device called the centrifugal governor, which keeps the velocity within an acceptable range. And it works like a figure skater putting out his or her arms as their arms go out, they slow down. As they come in, they speed up. So it keeps everything in an acceptable range. You can imagine that this was used later primarily in steam engines. And like many technologies of the time, right, James Watt kind of just brought it over to the steam engine. The technology came first and the understanding came later, like in thermodynamics. And then this man came along, and I swear this is the end of the little history trek that we're taking, although I hope everyone is enjoying it. James Clerk Maxwell, uh, the Scottish physicist who's best known for being the father of modern electromagnetism, he also looked at this centrifugal governor and said, okay, how the heck can we really understand this complex system? And he understood it in terms of a system, its input, and its output. And the goal is to be able to control and predict the system. So he formalized this idea of, okay, given an input, how can I control the state of a system? Well, first understand and then control the state of a system over time. That was called controllability, or it later became controllability. And the mathematical dual, the corresponding concept is to say, how can I understand the state of a system given its outputs? So in the case of a centrifugal governor, it's saying, okay, given the speed, the rotational speed of the millstones, how can I understand the state of where the pendulum arms are? And those two concepts are the two pillars on top of which modern control theory is built, and the far back inspiration for data observability today, where when we talk about observability, what we really mean is how can we understand the state of our data system given what we can observe about it, given all the little breadcrumbs that's leaving behind. In other words, metadata. So just to recap this part, the problem is data entropy. More and more data is coming in, we're using it, which is fantastic. However, things break, and that's inevitable. And what is the solution? One solution is to have increased visibility via observability, and that's where data observability comes in. So what is it? I'll tell you what it's not. Data observability and data quality are often used interchangeably. However, and this pains me to say as a data observability tool builder, is that data quality is a problem, but data observability is a technology. And what I mean by that is data practitioners do not wake up saying, oh, shoot, I wish I had a data observability tool, or at least none that I've met. And if you are one of those practitioners, please send me a message because I have a tool for you. But data quality is a problem, right? People wake up to Slack messages from their head of marketing saying that data is broken. And there are many ways to address the data quality problem. I would contend that it is not a fully solvable problem in the same way that if you had a software team guarantee that they can ship software without writing any bugs, I would call their bluff. Data quality is the same way. And the best that we can do is faced with this Sisyphean task of pushing a boulder up the hill, which at least know how long the hill is and grow stronger muscles over time. And data observability is a particularly good tool to help you have the information you need to know where exactly you are in the data quality journey and to give you all of the metadata you need to help empower people to actually have better processes to do this thing. And we'll talk about that later. So to go back a little bit, the pillars are the necessary and sufficient information to gain visibility into a certain system. It was metrics, traces, and logs in the software world. And for us, we want to think about it from first principles and say, okay, given a single table in your Snowflake instance, how would you describe that to a colleague? You might describe it in terms of, okay, this column has a certain distribution, right? Here's the mean, here's the standard deviation, and that column contains PII, and this enum has this many categories. And those internal characteristics we call metrics. And in contrast, you might have external characteristics. So given this table, but not actually looking at what's inside of it, just metadata around it, you could describe how many rows are in this table. What is the schema, right? How many columns, the names, the types of those columns, and when did this table land in your data warehouse, or when was this view materialized? That is the freshness. And these two characteristics, metrics, and metadata kind of scale independently so that you can double the amount of rows. So it's just like this glass of water, right? You can double the amount of water, but the temperature can stay the change. Alternatively, the volume can stay the same, but the temperature can change. So the distribution of data is kind of independent from the external characteristics and vice versa. And with those two, you described a single table. But clearly, data does not live in isolation. You have many, many tables in your data warehouse. And one important relationship to describe is lineage. This is something that is relatively novel to our world that we can't copy wholesale from the software world, where if you talk to an engineer, there's a common credo that treat your infrastructure like cattle uh, and not like pets. Meaning that if a box is in a weird state, kill it, recycle it, call it a day. But as data practitioners, we know that we can't treat our data like cattle. We have to treat them like thoroughbred horses, race horses, because their lineage matters. Because you can't just delete a table and hope for the best, right? There's so many downstream dependencies, and specifically lineage tries to codify the operational dependency between a given piece of data, whether it's a table, column, or a value, on other table, columns, or values, and some operation on those parents. And finally, logs describe interactions between data and the real world, right? The non-data world, whether it is ingesting from another system, it's input from a human, it's a data engineer merging in a PR that changes their DBT project and how data is being transformed, or it's a stakeholder actually looking at the dashboard. But the idea is that with these 4 pillars of information, metrics, metadata, lineage, logs, we can describe in arbitrary detail the state of our data system over time. And that if you were to be missing any one of these pillars, you'd be missing an important piece of information that makes it so that you can satisfy some important use cases. So let's hop into an example. This may be a little bit passé by this point, but we all remember Wordle. And let's say that in an alternate universe, Wordle was not acquired by the New York Times, but instead they raised $200 million from Tiger Global. And now the CEO and the co-founders and the board of Wordle are trying to go on a globalization rampage to upsell their 6-letter version to go into other languages, trying to get everyone in the world to play as much Wordle as possible. And in order to aid themselves on this journey, they hire a data team and enter the Wordle data team, where, let's say in the stylized case that Wordle is using Snowflake, they are replicating their Postgres instance into Snowflake, specifically email signups. They're using Fivetran to put Salesforce accounts data into Snowflake. They're using Segment to track and identify, users. And finally, they're using DBT to turn that raw data into final trial and 30-day usage tables that are being used within Looker, which is specifically being used by the growth team and execs, and finally putting that data back into Salesforce, which is being used by the sales team. This is a pretty common modern data stack, and I'll walk you through a few very common use cases for observability and how the pillars fit into that. So let's imagine that you're collecting metrics and metadata of all of your data tables. So for every table, we're tracking like the number of rows over time, how frequently they're being updated, the distribution of various columns. And one thing we might be able to catch is, okay, this 30-day usage table, the number of rows is pretty stable over time. Maybe it's growing, and then it tanks to 10% of that value. Now, if we were tracking over time the amount of rows on that table and had some anomaly detection, it could be quite simple, like tracking the mean. And if it decreases over a few standard deviations, send me an alert. That the metrics and metadata pillars are able to say, okay, this usage table deserves your attention. And this is critical because all of your systems can be running, right? Snowflake can be up. Your dbt jobs are running, but the data can still be incorrect. And internally, we call those silent data bugs, although they aren't silent when they reach the exec who notices it and then starts screaming. But it's a silent data bug that wouldn't have be that it would be very difficult to catch if you weren't tracking the historical values of this table over time. Now, if you sent this alert, then any engineer will say, okay, great, or not great. The amount of rows has tanked 90%. What can I actually, do about this? And using lineage, you're able to track two things. One is upstream to say that this 30-day usage table came from the usage table, came from tracks and identifies, and ultimately came from segment. You can tie that to a specific PR in dbt. And using usage lineage, you can help do this root cause analysis. Using lineage as well, you can see the downstream impact of these changes. So we know an issue occurred. We know that we can do something about it. But is it worth actually doing something about it? Because you're very busy. Your data team is extremely busy. If no one is using a table, maybe you can punt it to tomorrow and it's not a P0. But in this case, we can track, okay, this Looker dashboard and the Salesforce object both use this 30-day usage table. And using logs, we can understand that the execs and the sales team are using those objects. So with those 4 pillars of information, we can complete a full incident management workflow where we're able to detect, somewhat proactively when an issue has occurred, what the root cause was, what the downstream impact was, and who specifically is impacted by that downstream issue. So that's a stylized example. Now we can get into how do you actually put data observability into practice? And data organizations are obviously more complicated than Wordle, but we've spoken and work with hundreds of data teams, from small startups, humble but mighty one-person teams, to large enterprises with enormous data teams, with data platform teams bigger than other companies' data teams. And we've noticed a couple of, I would say, common factors between the teams that have found success with data observability and those who have more of a frustrating journey. And the first, I think, just like when trying to address data quality, when bringing on a data observability tool, it is extremely important to start from the goal, because otherwise it's this Sisyphean task. You're continuing to push up this boulder to achieve a final state that doesn't quite exist. And the best thing that we found is to say, okay, your downstream stakeholders, like, what is the actual problem that they want to solve right now? Right? What dashboards are they using? How frequently do they use those dashboards? And make sure that the data meets that goal. Because when data is being used, now it's finally fulfilling its purpose. And a few of the goals that we found for data observability, so here's 5, and it's an order of increasing abstraction, although it's arguably also an order of increasing importance. And the first one is saving engineering time. This is so prevalent, where when you get that message from the head of marketing that the data is down, wow, there goes your afternoon. And we already know how lucky it is to get focus time, and how focus time is the main ingredient to doing good data work. But that could be a goal. A second goal is, if data quality issues directly impact the revenue or the cost or the risk of a company. For example, if data is being used to talk directly with customers, that's a reputational cost if the data is incorrect. If it's being used to allocate ad spend because you train some machine learning model on historical ad spend and performance, that can be quite pricey, tens, hundreds of thousands of dollars, depending on your budget. Number 3 is, you may want to increase your data team's leverage. And we're seeing more and more, especially when the data hiring market is extremely red hot, that you want to maximize the amount of work that your data team can do without necessarily scaling the amount of people within your team linearly with the size of the company. Fourth, you may want to expand data awareness. So we like to say that even though the data team provides data to other teams to make better decisions, to understand the impact of their actions, that the data team themselves often don't have data. Which is to say, how do data teams know what to work on and how to prioritize their work and understand the impact? And frequently we have, gut intuitions, and that will take you quite far. But it's important to understand, how is data being used with other organizations so I can best use my team's time. And finally, you got to preserve trust, where the moment, getting data and using data is not enough. If the people using the data don't trust it, then it all is kind of has existential risk. But let's say that you've decided on two goals. You want to save engineering time and preserve trust. Repetition is required here, but the best way to make consistent progress towards a goal is to identify very clear metrics. For example, if you want to save engineering time, you can measure the mean time to identification or the mean time to resolution, right? Take a page out of the DevOps handbook. If you want to preserve trust, you might have a qualitative stakeholder survey, like an NPS survey, getting your users' opinion on the data that they're consuming. Or you might have an SLO or an SLA that holds you to some quantitative standard about how up to date the data is. But the important thing is that you have a goal, you have metrics that you consistently measure towards the goal, and you have people who are clearly identified to uh, be responsible for the direction of those metrics. Now, this is a tricky question because as much as Snowflake is the source of truth, it's ultimately not generating any data. It is a box into which you put data. Data is being generated upstream by engineering teams, by go-to-market teams, by product teams, and is being consumed downstream by data consumers. So given that data is produced and consumed outside of the data team, are they responsible for data quality, or is the data team responsible for data quality? And we've seen teams fall everywhere along the spectrum. We've seen failures and successes all the way. But one quick anecdote that I would like to raise is, why do doctors have notoriously poor handwriting? And one explanation is that doctors have poor handwriting because they never have to read doctors' handwriting. Pharmacists do. So the key variable that we've seen is, once you have buy-in from the data consumers and the data producers, who are often the same people, that once you have buy-in and some acknowledgement that their data quality issues are the results of the people on the team, not necessarily on the data team, that is when we've seen people be very successful. Finally, you can put some processes in place using those 4 pillars, whether it's trying to prevent issues up front by defining data contracts or implementing unit tests. You can have an active observability flow within your version control system, a passive observability tool that continuously monitors for these core pillars, and implement some playbook, for example, by identifying issues and remediating them and finally learning from them at the end. And lastly, okay, so you have the goals, metrics, people who are responsible for those metrics, processes that those people can put in place. That's where tools come in. And even though I'm speaking to you as a tool builder, tools do not solve problems in themselves, right? It's people who solve problems, and tools make it easy for people to solve those problems. And in our space, there are 3 different categories of tools, all with pluses and minuses. Open source tools are very customizable, but you have to maintain it. Building in-house is extremely customizable, but you have to pay the upfront development costs. And finally, commercial tools, perhaps not as customizable, but the time to value is faster, but the financial cost is higher. You can probably negotiate that for your own organization or try them out and see which one fits your needs. So finally, at Wordle Industries, let's say that the goal is to preserve trust. They can identify, SLOs for their top Looker dashboards and quarterly NPS surveys. The people involved, it's primarily the head of data. They're collaborating with business stakeholders. They have data unit tests, passive observability, and incident management. And finally, they could be using a tool like Metaplane, which I'll show you in just 1 second, where you can integrate across your data stack in 10 minutes. You have automated anomaly detection. You have instant lineage within the database and between your database and your BI tool. And finally, send alerts where your team already works. Okay, so let me take my presenter hat off and put my shilling hat on, because buckle in. We're going to walk into a very quick live demo where this is Metaplane. And specifically, I start on the homepage because you could start using it immediately. All that you have to do is sign in, and then whether it's through Gmail, OAuth, or you create an email address with a password, here you log in, and I'm just going to use my personal account for demo purposes. Now, this demo really has 3 parts. It's an order of, from most boring to most interesting, so bear with me for just a few minutes. But the first part is to get everything connected. Now, to get started, there's 3 steps. One is to connect your data source. Snowflake, BigQuery, Redshift, Postgres, we support the most common databases and data warehouses, and this list is only growing over time. And you've probably seen a million screens like this where you provision read-only credentials and then input it into your application. You can also integrate a data transformation tool like dbt or BI tools like Liquor Mode and Tableau. And it's important to note that every time you integrate an application, we automatically extract a lineage to every other application. So it's like adding a layer of observability into your data stack. And once you've connected everything, then you connect an alerting destination like Slack or PagerDuty or email. And finally, you configure some monitoring. So for many of the most popular data warehouses, we automatically deploy tests that are based on information schema, like row counts and freshness from information schema, which is effectively free in terms of incurred costs on your end. Now, once you integrate Metaplane, you get a few things off the bat. One thing which is quite simple are schema changes. So we're going to, every time a schema or a table or column is added or removed or renamed, we will alert you in your alerting destination and keep a historical record for you over time. Second thing is we parse your usage analytics for, we parse your query history for usage analytics on your tables and columns. So given all of the queries in the past months or year, what are the most popular tables? What are the most popular columns? What are the most expensive queries on those tables and columns? That can help inform which tests you need to implement, as well as what possible refactors are going to be a good use of your team's time. And conversely, what tables and columns are not being used and could perhaps be deprecated. And third thing you'll get immediately off the bat is lineage. So here you see a lineage from some tables to, for example, a mode integration, but we can dig down and say, what is the space within mode, and then what is this report? And finally, what are the specific queries in mode that depend on different tables? And what are the columns that depend on, what columns do those queries depend on? So we have really fine resolution in terms of our lineage. And this is being used every single day by data teams to understand, okay, I'm going to remove this table. Who do I need to let know? Or I'm going to update this report in a BI tool, and what's going to happen upstream. So those are all things that you get off the bat. Here is the core command and control center, though, and this is your data page. So on the left-hand side, you can see, okay, here's a database, schema, table, columns, and across the top are different types of tests. Now, previously, we covered row count tests and freshness tests, but you can go a little bit deeper and attach tests on the column level and say, this is the cardinality of an enum, the uniqueness of a primary key, the nullness of a column, or the distribution of, for example, a numeric metric. You can also create a custom SQL test where any SQL that returns a number or a result set will track that number or the number of rows in that result set for you. And there's 2 things to note here. One is that our philosophy is if it's not easy to add tests, then your team will not have tests. So if you want to add a nullness test on this customer's ID column, for example, you press a button and there you go. Now you have a test. And number two is a test means that now every hour we're retrieving that value either from metadata or by running a SQL query. And with this historical data, we have automated anomaly detection on top. So for example, in this customer retention table, we see that it's growing slowly 2.6 million gently over time, monotonically, and then suddenly it tanks to 200,000. And this we alerted the data team first thing in the morning. It was 5:06, and they were able to remediate this before anyone was impacted. Secondly, here is a customer orders table where we're tracking the freshness, and it's usually updated every hour or so. And our models take into account trends and seasonality. And even with that, it's 1:25 in the morning. It's been 3 hours. It's 9 a.m. in the morning. It's been 11 hours. And this is not what you want to see as a head of data. So they came in, they marked those as outliers, which I'll talk about in 1 second. And we're also able to fix that before the business day started. And although I'm showing you how Metaplane looks in the web application, the primary way that our users first use alerts is via Slack or some alerting destination, where you can see that this table, this dimensions table in the dbt production schema, we expected it to be updated every 30 minutes. And instead, it's been updated every 1.5 hours. Here are the upstream tables, here are the downstream tables, and crucially, here are the downstream looker dependencies. The last time they're updated, the number of times they've been viewed, and the name of the view. So clearly this is worth attending to. And what you can do here is give some feedback to our models. Right? If this is truly a true positive and you want to be continued to be alerted on this, you can mark it as an anomaly. Or if this was a false positive, because we'll never be 100% correct, you can mark it as normal and we won't continue to alert you on this, or you can mute it and collapse it. And what our customers love to do is kind of loop each other in on these threads to make it more of a social awareness where, hey, Guru, this table looks funky. Here's my co-founder, so I'm going to pick on him a little bit. This table looks funky. Can you please check it out? And that kind of completes the loop of Metaplane, where you set up these tests and we immediately extract logs, lineage, and you create tests to monitor the metrics and metadata so that now your team is the first to know of data issues. And you can do that all within 10 minutes. We've had highly motivated people do it within 5, although I'm not sure how they did it because I can't even do it in 5. Yeah, that's the end-to-end of Metaplane. And finally, with just a minute, we have to ask, what does data observability look like in the future? Because what we have today does the job, but it's still level 1. And we have to ask, okay, 10 years from now, 20 years from now, how does working with data look like? And I'm very curious for all of your opinions. Please type in the chat or just send me an email. But in 2042, I couldn't confidently say that any of the major databases would be around. Right? SQL will still be here. SQL will be here until the day we are gone, and far past that. But will we have batch data or streaming data? Will BI look the same, or will we not be looking at dashboards? It's hard to say, but it's hard to imagine a future where data teams are still operating the way they're operating today without data observability, which is kind of working in the dark and being more reactive. That data team 20 years in the future, I would put money on this, is that when they have a piece of data that's being used by a stakeholder, that they know exactly where it came from, all of the code that was involved, all of the systems that it touched, and they're extremely confident in knowing the downstream results of their changes, and that trust in data, instead of us trying to go up from 0 and build it up, will be maintained at 100. And the question is, how can we maximize trust? So finally, just to summarize, everything old is new again, but it's a vengeance. We're no longer dealing with clay tablets. That data observability tries to address the problem of entropy using concepts inspired from software observability, which itself is inspired by observability from control theory, which goes all the way back to windmills. The 4 pillars of data observability are metrics, metadata, lineage, and logs, which taken together can help us define in arbitrary detail the state of our data system. That these pillars address many use cases, including incident monitoring, root cause analysis, impact analysis. There's plenty of others as well, like spend management and trying to refactor queries. And finally, the most effective attempts that we've seen at implementing data observability have a clear goal, metrics, people, processes, and tools. And with that, happy to leave room for any questions that you have, although always check out metaplane.dev if you're interested. Just to play around, we have a sandbox, or feel free to get in touch as well. Thanks everyone for your attention.
Thanks, Gavin. No, that was great. Yes, I learned a lot. Learned a lot about data observability. Like I said, I think your website is actually up on the attachments as well. So easy click through. As he said, there's a sandbox there. Go and have a fiddle around yourself and work out some of these applications of data observability tools like Metaplane. I'm going to start with a quick question around a concept that you mentioned. A nice tie-in to the show as well. Actually, we've created a new theatre called Modern Data Stack. For anyone who's not familiar with it, what does it mean? Why is it different to what they might be doing if their existing architecture is what we could kindly say legacy, maybe? What is a modern data stack, and why is everybody wanting one?
Well, for one thing, I don't think the legacy is necessarily a negative term, right? Old is good, right? If it survived for 10 years, it will survive for another 10 years. The best predictor, the best restaurants in the city are the ones that have been around for a while. And the modern data stack, people define it in different ways. I believe the one core piece of it is the shift from ETL to ELT, where as the cost of storing data and within warehouse transformations has gone down, that the paradigm of extracting data from certain systems, transforming it in flight, and putting the final production data into your warehouse has shifted into one of, let me take all the things in A, put it into B, and then I'll transform it into C within the warehouse. And there are many downstream consequences of this. For example, how data teams are organized, what the flexibility of using various tools on top of the warehouse. But I would say that is the primary ETL to ELT shift, and the technologies on top of that, where you might be using an ELT tool like Fivetran or Airbyte into your data warehouse like Snowflake or Redshift or BigQuery, a transformation tool like dbt, and that's the modern data stack.
Perfect. And back onto data observability. Obviously, you showed us where it fitted in. Is there an advantage to baking this in at point of transformation, or if you add it afterwards, it makes no difference either way? Obviously, a lot of people who come to you presumably have already made this transformation, are already working in this particular way. Is there an advantage of when you're planning the transformation to plan the observability in the same time?
Great question. And what is the jurisdiction of data observability? There's arguments both to monitor it at the collection or transformation point, as well as to monitor it at the consumption point. And even in software observability, the open question of do you monitor the symptoms or do you monitor the cause is an open question. One argument for monitoring the causes is, well, if there's an issue in a dashboard, the damage is already done, right? Like that can help me mitigate the downsides, but it didn't help me prevent it from happening in the first place. The argument for monitoring the symptoms, right? So when things break is that's much more aligned with the end user, right? That's ultimately what they care about. And it cuts down on noise for everyone. And that it's much more centralized so that you don't have to trace a whole bunch of different systems to understand the downstream impact, but rather you have all of the issues occurring in one place, and it's much cleaner. It's easier from a problem-solving perspective.
Perfect. And I've got a couple of questions. One, I'm going to ask you anyway, because I've asked this question to observability companies, software observability customers, that I've spoken to on here as well at other shows. Is it just a word, or I mean, is there a, a a difference, a philosophical difference to like monitoring? I know it's are the two words interchangeable in your opinion, or is there something about observability that makes it super monitoring in some way?
You could use observability and monitoring interchangeably in 99.99% of situations, and people will know exactly what you're saying. The 0.001% of a nitpick is that monitoring typically requires you to define beforehand what you're monitoring. Like I'm monitoring for these key performance indicators or like these critical metrics in my database, while observability is more of a slurper that it's like taking everything and having all the metadata in one place, and you could have monitoring on top of that. And that more of observability is motivated by like you don't necessarily know what to monitor right now. You don't necessarily know what the root causes of any issues are, but we want to collect as much data as possible along the way so that when those unknown unknowns do occur, that you have what it takes.
Yeah, perfect. And I think we kind of picked up on the main advantage. One of the main advantages of data observability, such as saving, engineers time. Why is it so important? I mean, for some people that might be obvious, for some people not so much. But why is this such a big advantage for companies?
To save engineering time or any of those goals?
Yeah, well, I'll go with save engineering time, but yeah,
Ooh.
Feel free to pick another one into there as well.
Saving engineering time. Well, one, because there's a whole idea of like a manager's schedule versus an engineer's schedule, where 3 hours of uninterrupted time is how you get like the most out of an engineer, right? 3 1-hour chunks is not equal to 1 3-hour chunk, and if you want your team to be productive, that's the way to do it. And even more so, if you want your team to be happy and to retain the best technical talent and to attract the best technical talent, you want to be able to build a workplace that respects how they work and also makes it so that the work they do isn't like putting out fires and being reactive and not being celebrated for the wins for being, thinking ahead. So the data teams that we've seen that are having the most success at getting the most organizational buy-in, that are admired by the rest of the industry, have adopted this mentality that we want to build data like a product, that we're not going to be, slinging dashboards and putting out fires, although of course we will do that, but that we are engineering a product for the rest of the organization to build. That's why saving time is important, because as you're, putting out fires all day, you can't be thinking ahead.
Yeah, and as we found it, I imagine the same on your side of the pond too. It seems very difficult to hire good data engineers over here. There's a lot of there's a lot of demand for that particular job title. So yeah, treat them right. Yeah.
Enormous.
Yeah. Last question. You actually kind of answered it in your last slide, which was a bit of a bummer. But I'm going to rephrase it. Future of data observability, 2 years. What's Metaplane looking at? What new features can we expect in the short term before we look to the long term?
Before we look at 10 years from now, 2 years from now, where we and hopefully the entire data observability category is that we're able to integrate fully end to end within your data stack. That we're able to integrate with transactional databases, with upstream SaaS applications, and trace root causes all throughout the system. And not only that, but that we can help the data producers. So for example, if your engineer is shipping a schema change, that you're able to see within GitHub what the downstream data quality implications will be. As well as if you're the VP of sales looking at a Looker dashboard, you can see within that dashboard everything you need to determine how much you trust this data. Because again, it's the consumers and the producers that have to trust the data. And if they don't trust it, then the data is just not used to its full potential.
Perfect. Well, do you know what? It's been an absolute pleasure listening to you today, Kevin. Thank you for such a clear explanation of data observability. I hope everybody else has enjoyed it. I probably should have mentioned this before, but this session will be on demand almost instantly as we finish. So if you want to go through any part of Kevin's presentation or the demo again and pause and rewind and etc., have a closer look, then you can do that almost instantly after this. And then obviously it's on demand either on YouTube or on this platform. So like I said, pleasure to see you. Looking forward to meeting you in person in Big Data London in September. You'll be able to see Kevin in one of those theatres. I think it's the Data Ops Theatre on the first day as well, if you'd like to hear a bit more from Kevin. So thank you very much, and we'll see you very soon. So thanks, Kevin, I'll meet you in a few months, hopefully.
Definitely. And hopefully not everyone is too sick of me by then, but it's been a pleasure. Thanks everyone who was listening, and thank you, Andy.
No worries at all. I'll see you very soon. All right, thank you. Cheers. Bye-bye.